shown is a graph of the exponential function f of x equals 2 to the x power. For what value of x is f of x equal to 20? In other words, what exponent can we use on a base of 2 to get an answer of 20? Or we can try to solve this equation, 2 to the x power equals 20. Well, right now we don't know how to solve this equation, but we can approximate the solution, yes? How? Don't read ahead. Tell me how you think we might do it. Maybe we can graph? What do you want to do if we graph it? Of course it does this when I'm trying to show you, right? Does it do that to you when you guys are trying to show people? Okay, good. Da 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 da. So I would do what? A new document? No, I don't want to save the old one. I would graph it. Okay, so what am I graphing? 2 raised to the x power? Like that? That looks similar to that. Well, it should, right? Okay. What'd you say? I'm sorry, I just don't understand what you mean. So graph another line? So tab and put in 20? It's broken. Oh, my window's wrong. Okay, menu, window, settings? So what do I need to change in my settings? My Y max needs to be over 20. 25? Is that okay or no? Okay. How? How do I find where they intersect? Menu, analyze, intersection, lower bound. What the heck does that mean? I have to move it to the left? Oh, to the left of the intersection. Wait, wasn't it to the left of the intersection right here? But we want to be very clear, right? I want to move it a little bit closer, as long as it's on the left of the intersection though, right? Upper bound? Move it to the right of the intersection. Like right there? I can't really see that. That's messy. Oh, tap it. Like that. So what is x when y is 20? 4.32? So that really takes into account this category right here, right? Use a graph to solve the equation. What equation should be graphed? So in f of 1, we put in 2 to the x. In f of 2, we put in what? 20? And then what? Find intersection. Which was 4.32, comma 20, right? Is that the first way you would have tried it? Probably? Okay, good. That's good to know. What if I said you have to figure it out using a table? So I would say Control T. I have to change my table set to what? Menu, table. Look, I press down. Go down if I press down. 5? So start at point 2? So change this to point 2? Is that all I change? So why did I do that again? Okay. Why did we choose point 2? I have to be honest with you. I chose point 2 because Lucas said. And I think he chose point 2 because he was guessing. Is that okay? Absolutely. Right? Absolutely. So what am I looking for on my table? Where the y value is 20. It's not 20. So I changed my table set again. Edit table settings. So my table step, you want to be what? 0.0 what? Boring. This is boring. Probably why you didn't choose it first, right? So here's a question. When we found the intersection was at 4.32 and y was 20, is that right? What do you mean not entirely? Oh, if it's rounded, that's right. Okay. So what did we do to find our table? What did we use as table start? Yeah, it didn't matter, right? We started at 0. We obviously had a better place to start, but we started at 0. What about our delta table? What about our change in our table? 0.01. And then we looked for 20. Where? In the y's? Okay. Trial and error, my favorite. Yeah, we've already kind of done this both other times, haven't we? With our trial and error guesses about our table, our change in our table. We didn't really do trial and error so much on the graph, except we just had to change the window, right? How would we really do this? Between what two whole numbers does the solution fall? Would you know that automatically? What's 2 to the 4th power? 2 to the 4th power is 16, and what's 2 to the 5th power? 32. Well, 20 is between 16 and 32. Which one of those two is it closer to? Closer to 4, so it's probably going to be, the answer is probably going to be closer to 4, right? Closer to 4. So is there a way to solve this algebraically? Yeah, there is actually. Okay, there is. So what we have to have a way to do is a way to undo exponents. Okay? Much like we undo other operations and functions. If we're adding 4 and the equation looks like n plus 4 equals a, how do we solve for n? We subtract 4, so n actually equals a minus 4. And we figured that out by subtracting 4, right? How do we, when we're multiplying by 3 and the equation looks like 3n equals a, how do we solve for n? Divide by 3, divide by 3, so it looks like a over 3. How did we undo it? Divide by 3. What's happening here? It's being squared. And so we would right? And it would be the square root of a. So here's an exponent. How do we solve for n? This is new. This is new. Okay? Watch what it looks like. This is called logarithms. The way to undo exponents is to use logarithms. Okay? You got this so far? What does a graph of a logarithmic function look like? Well, exponential and logarithmic functions are... How are these two things related? How are these two things related? Ooh, not opposites. Opposites would be 5 and negative 5. Oh, inverses? Are squares and square roots even inverses? Oh my goodness. What do you think about these then? Inverses. If they're inverses, then what? How do we generate the logarithmic graph? Oh my gosh, I'm so proud of you. So if this was my exponential table, which makes sense, right? 2 to the negative 2 power, it's the same as 1 over 2 to the second power, which would be 1 over 4, which is 0.25. Remember that? Negative exponents. How could I get the logarithmic point there? So 0.25 and negative 2. So this would be 0.5 and negative 1. 1 and 0. 2 and 1. 4 and 2. 8 and 3. So what you need to realize before I go any further is this. With these calculators that we have, with the Inspire calculators, there's a lot less quote-unquote tricks that I have to teach you because the calculator does it for you. Okay? There's a thing called a change of base formula that I'm going to have to teach you. I'm going to teach it to you anyways, even though the calculator will do it for you, because here's the deal. I ran into a former student this weekend. Okay? And Jared doesn't know who it was because he wasn't with me. All right? And I'm not going to tell you their name because they asked me not to. But they asked me to tell you something. They went to college. Okay? They got to college. They had to take some sort of placement test for what math that they needed to take, because they have to take a math for their degree. When they went to take the placement test, they didn't let them use the calculator. I've taught you stuff and taught you stuff and taught you stuff first, and then showed you how to use it on how to do it on the calculator, haven't I? And I said, there's a good reason for this, because someday you might not have a calculator. And I said the same thing to this student, and they said, oh, I'm not ever going to have to know it that way. I'm not going to learn it. I'm just going to know how to use it on the calculator. And now the student is very, very, very bored in the math class that they're in because they had to go to a remedial class. They know how to do all of the math that they're doing because they remember it from my class. And now in the class they can use a calculator. They couldn't use a calculator on the placement test though. which I think is dumb, but nobody asked me. Okay? Please understand, when I show you how to do stuff first, before I show you how to do it on the calculator, it really is for your own good. I'm not just trying to be mean or make you do a lot of arithmetic that you don't have to know how to do or whatever, because you may. I'm not saying that's going to happen to you when you go to college, but it may, and I want you to be ready for it if it does. Okay? Deal? Okay, so back to here. We switched x and y. Now let's graph that. Let's see what this looks like. Okay? So 0.25, negative 2. 0.5, negative 1. 1, 0. 2, 1. 4, 2. 8, 3. Can I show you something that I've seen people do, even in here, that scares me? It does keep going, doesn't it? Okay, so where does it keep going? Here. Now, when you said it keeps going down, what does that mean? Is it going to go over here? Why not? Think about an exponential function. Does this ever cross the x-axis? It gets closer and closer to it because there is an asymptote here, right? If we're talking about an inverse function, what do you also know about right here for our logarithmic function? Yeah, there's an asymptote there. Okay? How do you read and write logarithms? I read that backwards, sorry. How do you write and read logarithms? What do their symbols look like? You do say log when it says log, excellent, excellent. Okay? First of all, this sentence right here, this sentence we're going to complete right here, it's pretty much a big deal. Just so you know. Okay? Like, this is the basis for this whole unit. It's not hard, it's just a big deal. Fair enough? Okay? So, if b to the x equals a, then this goes here. This goes here. And this goes here. Okay? What do you think this is called? Guys, what's it called right here? The base. Guess what it's called right here? It's called a base. Are they all exactly the same name? No, that would be dumb. Okay? This right here, the A. So the question you were asking me right now is, why is that called an argument? I don't have any idea. I really don't. That's just what it's called. Okay? No, we're not arguing about it. I'm saying it's called an argument. I don't know why. Okay? I mean, you guys can argue about it. I don't care, but I'm not going to argue about it. What's this one called? What was it called over here? It's called the same thing over here. Okay? So, how do you read this? Well, to be very honest, I've heard probably like 3 different ways to read it. There's not just one way to read it. Okay? That's how I read it because that's how I was taught to read it. Okay? That is not the only way to read it. Log base b of a equals